Hello, so we're going to start section 10.2, which is on quadratic functions. And so quadratic functions are a extension, well, not, let's say they're similar in idea to linear functions, except linear functions, you just have a bx plus c part. So you have a constant part and an x with a power 1 with a coefficient. And to make it quadratic, we add on an x with a power 2. And doing so changes the behavior of these functions quite a bit because, as we know, x squared doesn't quite behave the same way that, say, x does. So, as the most basic example of a quadratic, and really the most important, is y equals x squared, which we may recognize as the standard parabola. Now, part in our discussion is going to show that this is the example we want to keep in our head as to what a quadratic is, and that we can think of all quadratic functions essentially in these terms. But in order to do so, we need to show that every quadratic function that has a form like this could potentially be written as something like a to the x minus h squared plus k. Now, it might not be entirely clear why we would want to take something like this and rewrite it like that, but in a follow-up video, I'll go on Desmos and show us the significance of the fact that this is the form of a quadratic as well as that, and what the implications of that are. But to show that something like this is possible, we should first note that it is certainly possible for me to factor out the x squared, or to factor out the a out of the first x squared term. All right, so if I can multiply this a back through, I would get ax squared plus bx, just like before. And we should note that I can also multiply this term by 1, so I can multiply by 2 and divide by 2, which is the same as multiplying by 1. And so I haven't changed any of the values from this step to this step. Now, this might start to look familiar because we might have recognized things, say, so like parenthetically on the side, things like x plus 1 squared is x squared plus 2x plus 1. When we FOIL that, we essentially get two copies of the x here, or of the times the 1 here. And so something similar is happening here. We have two copies of the b over 2a times x. And so it would be nice if the last term here is this 1 squared. It would be nice if I could add in a term like that here. But in order for this thing and this thing to be equal to each other, I can't just willy-nilly add whatever I feel like. I still have my c. If I add here, I have to subtract out here. So what I subtract is minus b squared over 4a squared times this a, right? If I multiply this thing by a, that's added on here. That's an extra term I snuck in here. So I have to counteract by taking that whole thing off. And now this thing here, this can be expressed as x plus b over 2a squared. And if you don't believe me, you can go ahead and FOIL this thing out, and we would get exactly these terms here, plus c minus b squared over 4a. All right, that a and the a squared cancel. And so we take this, and that's turned into that. And I could call this thing here k, and this thing here minus h. And I have taken something like this and rewritten it into something like that.